In the previous video, I clarified the distinction between coding as well as algorithms. Throughout the course, we'll focus on a mix of both, which is you'll have the opportunity to practice these implementations on Stepic while we'll be testing your algorithmic thinking or your approach to solutions on different algorithms or data structures in different exams as well as quizzes. In programming 1 and 2, you might have encountered that we typically can solve a particular problem in more than one ways. And why that's important is you'll know in just a little bit, but we can discuss that by giving a particular problem. And in this case, we have a problem of determining if a sorted array contains any duplicates. So in this problem, you are given an array that consists of some numbers, and these numbers are already sorted, which is you have these numbers from -13 and they end at 102. One way to solve this particular problem is by comparing two numbers one at a time for all the possible pairs, which is you compare -13 with 11, you compare -13 with 12, you compare -13 with 14, -13 with 24 till you reach the end of the list. And if you do not find any possible duplicates, you basically move the pointer from the first element to the next one in another loop, and then you do the same, which is compare each of the pairs one at a time. This algorithm is absolutely correct and will give you the correct answer, but it's a bit slow and a bit naive because we haven't used the particular property that we have been given, which is the array is sorted, to solve this particular problem. What I mean by that is, whenever we are trying to solve a problem, you need to understand that we have to understand the characteristics of the data that's provided to a particular algorithm. So, since we already know that this array is sorted, what we can do is we can just compare adjacent elements and see if they are sorted or not. So in this case, like the earlier case when we were doing pairwise comparisons, that's a naive way or a very silly way of solving that particular problem. So that's like comparing every possible pair. The second approach that we just discussed, which is since this is already sorted, we can just compare adjacent elements. And why we can do that is because since we are finding duplicates in a sorted list, we know that like if they are duplicates, they should be adjacent to each other. And if we do not find that the two adjacent elements are not equal, which is they are not duplicates, we can move our pointer to the next one and move across the list. This would require just one for loop or a while loop compared to two for or while loops in the previous algorithm. It's a much better algorithm to compare adjacents and find duplicates. This raises a question, which is, are all programs or algorithms equal in terms of performance? The correct answer you might identify with through our approach to solving this particular problem is no, because not two algorithms are basically two different algorithms are different in terms of performance. And we know intuitively that the second algorithm is better, but in this particular module, which is this week, we are going to discuss it more formally, like how we can evaluate two algorithms in terms of performance. And since we are computer scientists, we need to better define what performance is, because this is a very subjective term. Like performance for you might mean money, while performance for me might mean time.